Minasan, konnichiwa, samurai directors. So in this video, we will explain one example of the use of MU decomposition to determine the matrix inverse for the previous example. The previous example, we have the following given. Right? Actually, the given is a matrix. We have the unknown variable vector equal to the known constant vector B. So this is the generality of and on that example, we were asked to decompose matrix A into two submatrix or component matrix we call upper and lower triangular matrix. Right? So we will give the benefit of the doubt that these values are supposed to be correct. Right? So we will use these values in our example. On the current here, we are going to do this. No? And finally, actually, not only to determine the matrix inverse, but actually solve the unknown value of x. Right? Solving for x. Right? So first major step is D. How to solve for D? So the step solution. So solving for D, we will use the equation LD is equal to B. Solution. Let's begin a bigger solution. L, which is a matrix, multiplied by D is equal to vector B. So this is the first step. Wherein we have a given. So therefore, we need to find D. So therefore, then let's write down the given. Lower triangular matrix, of course, we have 0.0, 333, 1, 0, and 0.1, negative 0.02, 713, which I have just copied from the given above. Okay. So multiply by unknown vector, which is D1, D2, and D3. Therefore, by back substitution, using the constant value of B, which, what is the given? So, the constant value of B is 7.85, negative 19.3, and 71.4. Why? These values are from the previous example 10.2. Right. So when we have this equation now, this is now the process of back substitution. Immediately we know that 1 times D is equal to 7.85. Therefore, immediately we have the value for D1, which is equal to 7.85. Right? Because we have 1, 0, 0. 0 multiplied by D2, 0 multiplied by D3. Therefore, 1 times D1 is D1, which is equal to 7.5. That's why immediately, at that instance, directly we can show the value of D1. Okay? And next one, the second line, 1, 2, 3. So we have a value, 1 and 0. So therefore, 0, this will be multiplied to D3, therefore D3 is eliminated. So we only have D1 and D2. And take note, we already have the value for D1. So we are actually looking for the value of D2. So multiplying 0.033333 multiplied by D1 row multiplied by column D1 1 times D2, therefore D2 is equal to negative 19.3. Right? Therefore, we immediately know the value of D2. D2 would be equal to negative 19.3. So this one transfer to the other side, this will become negative. So negative 0.033333 multiplied by 7.85. Please check in your calculator. Post mo. So the answer is in your calculator. The answer would be negative 19.56, no? So, answer negative 19.56, 166, right? And then the last one, we're going to find out the number for D3. So therefore, multiply this row, so this vector, 0.1 times D1. 0.1 times D1. Then negative 0.02713 times D2. 0.02713 times D2. And then 1 times D3. That is D3 is equal to 71.4. 71.4. We have this. Therefore, we already know the value of D1 and D2. We substitute, and then we can find the value for D3. Therefore, we have D3 as 70. Is this correct? Please, please confirm. 70.084292. Right? So, those are the value for D. We already have the value for D. Therefore, we already know D. So, substitute this value, and then we already know U. We can find the value for X. Right? That is very fast. No? So, because we have what? U, X, which is the unknown, and now we have D. Therefore, write down the value for U, 300. This is a upper triangular matrix. We have following multiplied by the unknown. What are those unknown? X1, X2, and X3. And we have the value for D1, which is 7.85. D2 is negative 19.561666. And then $70.084292. So these are the values. So let us use again another box substitution. But this time we can solve first the x3. So we can solve x3 first. Because x3 multiplied by this one equal to this one, therefore we can just divide 70.084292 divided by 10.0120. So divide by 10.012. So the answer is we have 7.00 0, we have 4 zeros, then 2, 9. So it is almost 7. The value is 7. Okay? And then let us go to x2. So this one is to be multiplied by x2. This one is for x3. This one is 0, which eliminates x1. Therefore, we have 7.00333 multiplied by x2. Then we have negative 0.29333 x3 is equal to negative 19.561666. Right? So therefore, multiply this value by negative, right? And then this will become negative. Put it to the other side, it will become positive. So multiply by 12.29333, and then algebraically add to this, which is negative 19.561666. The answer is negative 17 divided by this one, divided by 7.00333, and we have the answer, which is x2, so negative 2.5. How many zeros? 1, 2, 3. 1 plus 2.5. So the next number here is actually 2. But because I am using 6 decimal digits, so I leave it as blank. No? So negative 2.5 is enough. Okay. So positive 7, negative 2.5. And lastly, we have to solve for x1. So we have 3 times x1. The negative 0.1 times x2, the negative 0.2 times x3, which should be equal to 7.85. Therefore, we can just substitute these values in this equation, and we have negative multiplied by 0.1, which is negative, will become positive. Put that to the other side, it will again become negative. No? So multiplied by 0.1, it is negative 0.2500. Then algebraically add to 7.85, and then this one is negative, will become positive on the other side, positive 0.2 multiplied by 7, and the result is actually the value of x1, which is about 9. We have actually 5 zeros, and the next number is 57. So I just rounded up. You see? So these are the values of the unknown x. So therefore, finally, you may just write it just to present it as your answer. X1 is 9, I do it, something like that. And x2 is negative 2.5, and then x3 is 7, and just give this as your answer. Right? Any question? Any question? this is how fast these values are using the two steps. Major step, this one, this one. But preparatory to this, because this author uses LU decomposition, we have the value for LU. So before you can go to the first major step, first find out the value of L and U. U and L. Okay. Are there any question? This is your chance. Question. Question. Any question? None? Okay. So thank you.